This video is for the parallel circuit. So let me draw a parallel circuit. And if you watch the other video, it's going to have the same resistor values as the last video. And so I think that's important so that you can see how it differs despite having all the same values. So 3 ohms, 10 ohms, and 6 ohms. Again, it's R1, R2, and R3. That is terrible. R1, R2, R3. That's a little better. So this is called parallel because there are multiple paths. You can see my current at this point could continue on straight, or it could turn right. At this point it can continue on straight, or it could turn right. Because of the multiple paths, multipath, not all of the current is going through every resistor. So it's a parallel circuit. So let me kind of erase those red lines. Multi-path. And parallel obeys rules just like series does. So here are the parallel rules. It's kind of almost exactly opposite. Voltage now is going to be equal across every resistor. It's going to remain constant. The same voltage is just going into 2 different places, but it's the same wire, and so your voltage isn't going to change. Nothing's really happening to your voltage. Current, however, is now going to be equal to the sum of the parts, and this is Kirchhoff's first rule, or the junction rule. Kirchhoff's first. If you recall, that's at any junction, the current going in has to equal to the sum of the currents coming out. Here's where parallel gets a little different. Equivalent resistance is equal to the reciprocals, the inverse of the reciprocals of all of the resistors added together. Excuse me. And so here's how we would calculate that. So I have resistor 1 is 3, plus resistor 2 is 10, plus resistor 3 is 6. If you recall in the last video, 19 was the equivalent resistance. Well, 1/3 plus 1/10 plus 1/6 is 3/5. And if I do 1 divided by 3/5, I'm basically just flipping it to where it's 5/3, and that's basically 1.66666 repeating. So again, I'm going to round that, and we'll just say that it is 1.6667 ohms. So that's our equivalent resistance. So now, if I know my applied voltage is 9, and I know my equivalent resistance is 1.6667, I can use Ohm's law, V equals IR, and I can solve for current. So 9 divided by 1.6667 excuse me, gives me 5.3999. So 5.3999 as a current. That is supposed to be a 5. Goodness gracious. Alright, and so now what's difficult here, though, is current isn't going to be the same in each of these resistors. In fact, all of those currents better add up to be 5.3999. What's the cool thing, though, is that if 9 volts come here, Well, all that's changing is the wire. So 9 volts is going to go that way, it's going to go that way, it's going to go that way. So 9 volts are going to be across each of those resistors. So kind of like in the series example, if my voltage isn't changing and my resistors aren't going to change, they're not variable resistors, then all we're doing is going to calculate for I. So when I'm doing V1, V2, V3, all of those are going to be the same. 9 volts. What's going to change, though, is I1, I2, and I3. And I just do that simply by doing V equals IR again. So 9 equals I times 3. So 9 divided by 3 gives me 3 amps of current across resistor 1. 9 divided by 10 is 0.9 amps of resistance across 2. And 9 divided by 6 is 1.5 amps across resistor 3. So let's add all of these together and see what we get. 3 plus 0.9 plus 1.5, I get 5.4. That is pretty darn close to 5.4. So that is how you find the voltage and current across resistors in parallel. But I really want to show Kirchhoff's junction rule. So I had 9 volts and I had basically 5.4 amps come into this junction. 3 of it went that way, meaning 1.4 had to go that way. So now I have 1.4 amps coming into this junction. 0.9 of it went that way, meaning 1.5 of it had to go this way. Sorry, this is 2.4. See, even teachers make mistakes with their math. So I had 2.4 going into there, and so when the 0.9 went this way, 1.5 continued. So that shows that the amount of current going in has to equal the amount of current going out. That's Kirchhoff's second rule, and voltage is the same across each one. So sorry for that last confusion on that one. If you have any questions, please let me know.